one simple instruction. All it says is simplify. Okay? What that means this is not a simple word, actually. You have to know that simplify in mathematics ends up meaning hundreds of different things. With radicals, simplify means write things as mixed radicals and then combine like radicals. So you have to see, first of all, can you simplify it into a more basic family member? Are there things that you could pull out of the square roots? And then once you've done that, then you're going to be asked to combine like radicals. Now, in previous questions, in the example 2, they said, where is it defined? And we had to take extra time to say that it only works if r was greater than 0 or so on and so forth. This one doesn't ask where it's defined and actually gives you where it's defined. So if we go to our highlighter, change colors, ooh, green. This part of the question in each of them is telling you where it's defined. That's not part of the question to be simplified, but that green part is saying this first one is only defined if both n and m are bigger than or equal to 0 or positive. The second one only works if b is less than or equal to 0. And the third one only works if both a and b are greater than or equal to 0. So they give you where it's defined, but that green part isn't part of the question. It's just additional information. What we have to simplify is the stuff before the comma, which is 7 root m's plus 2 root n's plus 5 root n's minus 3 root m's. So they're already written as mixed radicals. We look inside the square roots, and there's nothing we can pull out of the square roots. So then we have to look, are there radicals that are alike, that belong to the same family? If there are, we can put those together. Can you see here that I have 7 root m's and later I have minus 3 root m's? That will leave me with 4 root m's. I have 2 root n's plus another 5 root n's. That will leave me with 7 root n's. Can we put those together? No. So this is completely simplified because we have written them all as mixed radicals and we've combined all the like radicals. So we're done. For part B, again, I would look first inside. Can I simplify that negative 3b? No, I can't in the cube root, and I can't in the square root either. So it's already been simplified. Now they're all negative 3b, but we have to be careful because here we have cube roots, and here we have square roots. So they're not alike unless they're identical. They would both have to be cube roots in order to combine them. So when we combine this one, I have 2 cube roots here minus 9 cube roots there. That would leave me with negative 7 cube roots of the negative 3b. And with my square roots, I have 8 of them, and later I add 3 of them,
So that's 11.
giving me 11 of them. And so we have combined our like terms. They're all written as mixed radicals. We have simplified this. For the last one, we have things that have not been simplified yet. So we're going to take the time to rewrite them. Okay? I have 3 and then a square root. Now with a square root for 32, I'm going to look at my perfect squares. What is the biggest perfect square? 4, 9, 16, 25, and so on. What is the biggest one that divides 32? 16. because 32 is 16 times 2.
Does that say cube root or is 3 a
It's a 3 is a coefficient. I should make it even bigger. There we go. I don't know, for the a to the 5, one strategy you can do is write out a 5 times. Because every time you have a pair, you're able to bring 1 out for a square root. So I'll write it like this right now. Yes? Okay. This is going to take some time to write it all out. Minus 2 square root. What is the biggest perfect square that divides 45? 9. 9 times 5, and I have 3 b's, so it'll be b, b, b. Then we have plus 5b out in front, square root 125. Is there a perfect square that divides 125? 25 times 3. And we have only 1b in that one. And finally, minus 2a. What is the biggest perfect square that divides 72? 36. 36 times 2, a. So I'm just setting this up right now to simplify. Because now, this is going to equal, this square root of 16 is going to become a 4. I can pull it out of the square root in front, it's going to become a 4. But there's already a 3 out front. If I pull a 4 out front where that 3 is, should I get 7 or should I get 12? 12. This one here, this 5 here? This one here? Because I had 125 to begin with. And 125 is 25 times 5. Yeah, that's a good question. That's a good question. How come I wrote a 3 instead of a 5? It should be a 5. Yeah. So this 16, the square root of 16 is 4. When I bring that out in front, I'm going to get a 12. I have a pair of a's here, another pair of a's there.
So that'd be a squared.
It's going to be a squared when it comes out.
And we had square root of 10a.
What's left inside is the 2 and the a. Oh, better pause. Fire. Ooh. Yeah, the fire drill should probably come up on there. All right, so we're back. We're survived. Nobody got burnt. It's all good. We had done the first one right here. We had already simplified that first one, and we are on this one now. So again, we look at the numbers. We've got a square root of 9 inside. So that's going to come out in front, and it's going to come out in front as a 3. There's already a 2 there, so 2 times 3, you'll have a 6. We have a pair of b's right there, so when that comes out in front, there'll be 1b. And what we're left with is a 5 and a b inside that square root. Yes? In the one before, the a that was left stayed inside. So on the third one, we've got a 25 inside. That's going to come out in front as a 5. There's already a 5 there, so we have 25. We have nothing else, the variables. We don't have a pair of them to bring out. We still have a b out in front, and we're left with a 5b inside. Question?
25 times 5.
25 times, well, when we bring this out in front, right, what is the square root of 25? It becomes a 5. And then that 5 gets multiplied by the 5 to become a 25. Okay? That's the place where you're going to, you're going to really have to be careful, because you're going to see yourself making those mental math errors when the number that you're pulling out in front, okay? And sometimes people get radical happy, right? They pull it, they see 25 and they're like, oh, I know, that's 5. I can keep taking the radical. And they just keep going and going and going until there's nothing left. Just calm down, right? You got it, just the 25, and that's going to become a 5, and it gets multiplied by 5 to get 25 in front. And finally, in the last one, we have a 36. So that's going to, when that comes out, it's going to come out as a 6. It gets multiplied by that -2, gives us -12. We have a pair of A's inside. One A is going to come out, but it's going to hit the A that's already there. So we're going to get A squared, and we're left with 2A. We do have some like radicals. So step 1 was changing everything to mixed radicals. Step 2, let's look for ones that are alike. I have a √2a and a √2a. So if I have 12a squared minus 12a squared, -0, no, just 0. And if I have a -6b plus 25b's, I'm going to get 19b √5b as my final answer. And the one you can do for practice is question number 8.